Hello and welcome to the Erlang Solutions monthly webinar. My name is Mladen Miličić and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we are organizing across topics of interest in the world of Erlang and dealing with solutions based on the Erlang programming language. Today we will be hearing about Sportsrisq, a broker and distributor of risk management solutions and products focusing on the sports industry. We will be specifically hearing about Sportsrisq's decision to migrate components of their Python-based core platform into Erlang and the motivation behind those decisions and the outcomes this produced. Now, we'll be running this event live, so please be patient with us if there are any technical issues. But to start by telling you a bit about Erlang Solutions, we are a products and services orientated company completely devoted to the Erlang programming language and increasingly Elixir. We work with organizations and individuals using Erlang and Elixir, helping them evolve the language and supporting people and businesses using it. We are headquartered in London. We have offices in Stockholm, Krakow, Budapest, San Francisco, and Buenos Aires. We run projects that span industries and the globe itself, and we develop Erlang-based products as well. Some of those include our Mongoose IM messaging platform, which is open source, the React distributed database, Wombat OAM, our monitoring and management technology for Erlang and Elixir systems, and a number of other products. I'm really pleased to say that our speaker today is Sportsrisq's CTO, Justin Worall. Now, please allow me to finish by saying you are very welcome to pose questions throughout the duration of the webinar by using the chat facility on the webinar's interface. Our speaker, Justin, will answer as many questions as time allows at the end of the webinar, but should any questions go unanswered, you are most welcome to raise them via email using the following address, webinar@erlang-solutions.com. If you're interested in learning a bit more about Erlang in general, or wish to understand whether it could help you and your own business, then by all means feel free to contact me directly. My email address will be displayed in one of the final slides we will share with you today. I would now like to hand over to Justin, who will be glad to start us off.
Okay, all right. Well, good afternoon, everybody. I hope you can all hear me successfully. I've had a few problems with my Windows setup here, so if there are any issues, I'm hoping the Erlang Solutions people will be able to jump in and correct them, but I'm very hopeful it will all go successfully. Erlang Solutions have told me that I can't actually see how many attendees are here. Oh, we've got 40 so far. Okay, oh, well, that's great. It's good to have a few people interested in Erlang and sports, which I think is an interesting topic. I hope, you know, over the course of the next 40-45 minutes, I can maybe, I was going to say educate, but that sounds a bit prescriptive. Maybe I can, you know, tell you a little bit about our story, you know, our journey from sort of Python to Erlang. Maybe educate you a little bit, maybe make you laugh a little bit in places. So that's basically what I'm going to try and do here today. A little bit about me first. I am sort of midway through my career. I started work in the 1990s working for Morgan Stanley, the US investment bank, which I joined straight out of college. And I did a lot of work for 15 years there, pricing and trading and structuring derivatives, fixed income derivatives, that is bonds and swaps and stuff like that. And when I joined Morgan Stanley, I knew nothing about computers. I was not a child prodigy. Even though we had one at home as a kid, I was not a child prodigy. But when I started in my first week, the guy I was working with basically put a fat manual on my desk. And in those days, this is all pre-Windows, pre-Excel. You know, it's that long ago. We basically had Unix Sun stations with copies of C and APL on them, and he put this fat APL manual on my desk and said, "Get learning if you don't want to be fired." And because I was in my early 20s, that was what I did. I started learning this stuff, and I don't know if any of you are familiar with A+, but it's to the uninitiated, it's extremely terse. It makes Perl look verbose. but you can do an awful lot with it. And Morgan Stanley, in their wisdom, had actually built their own dialect of APL called A+, which they subsequently regretted because they found no one wanted to come and learn it. But I cut my teeth on APL and A+ for 7 years before deciding that that was a bit of a dead end career-wise, and branching out, looking at other languages, looking at Java and deciding it wasn't for me, looking at Python and deciding, well, that actually looks pretty good. Working with Python for a number of years, and ultimately really sort of bumping up against the limits of what Python can do as an enterprise system, particularly with respect to things like its global interpreter lock and its lack of threading. Discovering Erlang, this weird language, and finding over time that actually, yeah, Erlang solves an awful lot of problems that Python was leading us into. And really just what a great application environment Erlang is. And you know, that's been a journey of sort of 20, 25 years. But I mean, the Sportsrisq part is much shorter than that. But we'll get onto that anyway. So I'm going to click the slide. Right, some apologies. Let's get this out of the way. You may have gathered I have no formal training in any of this stuff. So if you're looking for a hardcore computer science presentation, this is probably not for you, because I majored in philosophy and I know enough to be dangerous, but not always to be useful. The second apology is that this was advertised as a low latency event. So I should probably explain a little bit about what that means. I mean, it's not low latency in the Jim Simons, Renaissance Technologies, high-frequency trading kind of stakes. We are not doing C++, optimizing every byte. We are not building, you know, our own hardware to do this stuff quickly. The sort of latency that we have in our industry is about half a second to a second, and most of the APIs that we're dealing with are all web-based, so you know, there's a certain latency in that. You know, and if we're able to do a lot of web requests in parallel, you know, 50 to 100 web requests in parallel to APIs at frequencies of about half to 1 second. That works pretty well for us. So it's not traditional C++ high-frequency stuff, but it's certainly stuff that Python finds hard. But on the other hand, Erlang finds fairly easy. So that's kind of the place where we are, as it were. Okay. So position insurance. Okay, well, this is a little bit about what Sportsrisq does. Okay, so Sportsrisq is in the sports insurance business, but what does that mean technically? Well, the example I always use is this one. I mean, imagine a team, which will remain nameless, who are expected to finish 10th in the Premiership. Now, if they do well and finish 6th, a couple of things happen. They will qualify for Europe, which means more TV money. That's good. If they do so, it will likely trigger more goal-related bonuses that they have to pay their players, and that tends to be bad. Now, if football was a well-run business, you know, those things would generally offset, but we all know that football is obviously not always a well-run business. And so you often, well, I won't say often, but occasionally you get situations where teams actually find that the better they do, you know, the worse off they are because they haven't managed it properly. Or they may have sort of explicit goals. They may literally have a schedule of goal bonuses that they need to hedge, you know, for their players. And so the question comes in, you know, often we get situations where it's like, okay, we're expected to finish 10th, but if we finish 6th, we're going to need, you know, X million dollars or pounds. Now, if you're familiar at all with finance or insurance, you'll see that that's very like an insurance product or an option product. It's like a contingent thing. You know, if the team finished less than 6th, then there's no payout. But if they finish higher than 6th, I should say lower than 6th, there's no payout. But if they finish higher than 6th, then potentially there is an obligation there. And as soon as you start to realize it's an option, it takes you into probability territory, into pricing territory, and you know, a lot of issues which are similar to finance and potentially can be quite fun and interesting to figure out. So that's kind of an overview of what Sportsrisq does, or at least one aspect of Sportsrisq. I shouldn't say that's the only thing we do, but that is an interesting product where we've done well. So, finishing positions. This is a graphic. You know, we spend a lot of time focused on graphics like this. Now, it's a bit small at this side. I hope you can see that. I'm not going to increase the size of the font because every time I do, Windows seems to crash. So I'm just hoping that everyone can see the axes here. We spend a lot of time focused on graphs like this, you know, which show where different teams are going to finish at the end of the season. Now, this was taken a few months ago, so it doesn't reflect Leicester's rapid rise. But even so, you can still, assuming this was taken in March, you can still see some interesting stuff. Like, Man U, even in March, were pretty much nailed on to finish 5th, which I think is where they did finish. As are Aston Villa, finishing bottom. That was pretty clear early on. Also, if you sort of squint your eyes up a little bit, you can see that the division sort of forms into various blocks. If there's sort of a square block for the top 5, there's then another sort of square block for numbers 5 to 10, and then down at the bottom from 11 to 20, there's sort of a bigger, more indistinct block. And the intensity of that particular chart shows you, how nailed on certain teams are for certain positions, and who their nearest competitors are. And that's interesting for us because, we're pricing a lot of contracts whose payout is based on these finishing positions. If you think of a lot of contracts that are out there, who's going to win, who's going to finish in the top 4, who's going to finish in the top 6, who gets relegated, who finishes in the top half, bottom half, all this kind of stuff, it's all related to finishing positions. So a lot of what we do is focused on finishing positions. How do we do that? Okay, so Sportsrisq workflow. Well, we take a lot of publicly available data, and then, we do stuff very similar to what a lot of big data companies would do it. We have to clean it all. That's the data cleaning part. Core to our business is, given all this public data, we try and assess exactly how good each team is. And by that, I don't necessarily mean, where each team is in the current league rating, because often the league table, you may have heard the saying, the league table can lie. Maybe the saying is the league table can never lie. Well, in our opinion, the league table certainly can lie on certain occasions. You can see that quite easily just from Leicester's position. I mean, Leicester have won this year, but does that make them the best team in the league? Well, if you look at the prices for next year, probably not. I think Leicester are something like 30 to 1 to repeat their feat of 2015-16, whereas the favourites are still Manchester United and Manchester City with their new managers, respectively. So a lot of our focus is on trying to gather from publicly available information stabilized ratings for exactly how good different teams are. And once we've got those ratings, we can do quite a lot with them. We can basically simulate the rest of the season, and once we've simulated the rest of the season, we can get position probabilities for all these teams. We can calculate contract values, such as who's going to win, who's going to finish in the top 4, all that stuff. And we can also assess risks, so we can do a lot of what-if simulation. What if Leicester win their next match against Liverpool? What does that mean to these numbers? And those risk numbers and marks are very useful for trading, for risk management, and for a variety of sports risk products. So that's kind of our workflow, and it's split, between the public stuff on the left-hand side and proprietary on the right. Right, next, top 4. Okay, so here is a quick chart of what happened in the top 4 this year. Lots of volatility. Again, taken I think sometime in March. Now, what can I pick out from here that looks interesting? Well, you can see Man United in the dark blue, and they've had a precipitous decline. They haven't done very well at all. They sort of declined sometime. I guess it would be clearer if the axis on the bottom was in actual dates, but instead I've done it in days since the start of the season. But you can see Man U have just suffered a fairly precipitous decline under Mr. Van Gaal from about mid-November, December. Chelsea did even worse. They were out of it by, looks like, September, October. And then you've got the newcomers. You've got Tottenham in purple, who have risen all the way throughout the season. And then, of course, you've got Leicester, who rose at a slower pace in the green, but obviously we're right in there at the end. So it's been a very interesting season. Teams-wise, you'll all know, this is nothing new, that the incumbents have done very badly, or the guys, the oligopoly, as it were, have done very badly, but the newcomers have done very well, and it makes next season start to look very interesting in terms of what's going to happen. So this is a standard output that we would track. A bit less volatility here, but actually potentially more of interest. These are our internal ratings graphed over time. We measure them on a range for each team between 0 and 3. 3 means you win every game, 0 means you lose every game. The big trend here is how much the dispersion of the different ratings has narrowed over time. So you've got all the guys at the top, Man Cities, the Man Uniteds, the Arsenals, all declining. Man City from 2.1 down to 1.9. Man, let's see what. Trying to pick out the green, but I can't. Arsenal are pretty much stable. And then on the bottom half, you've got all the risers. You've got Tottenham gone from 1.5 all the way to about 1.8. And then you've got Leicester sort of rising from the deep, like George in purple, all the way from 1.2 to 1.4, 1.5. So there's a couple of interesting things you can say there. I mean, first is that, even though Leicester won, they're not rated as a top team. They're still maybe 7th or 8th best in the Premiership. But also how next season is going to be a lot more interesting because all these teams, in terms of rating, are much more tightly packed than they were before. And, potentially there's teams there which I haven't even included, which would be in the mix. I mean, if I included West Ham and Crystal Palace as well, they would also be in there. So again, very exciting next season. Markets. Okay, just a quick markets cloud, not very interesting. This is just a range of different stuff that we can price. Now, does it all work? Well, we like to think it works. I mean, let's talk Leicester again. I mean, at the start of the season, we would all, well, you might have read in the press, there's been an awful lot of talk about risk management and how much money the bookmakers have lost on Leicester by offering 5,000 to 1 odds, to people, and they've been taken to the cleaners. And that's all true. Well, our model would have done even worse. We would have said at Leicester probably had 1,000,001 chance at the start of the season of doing anything at all. But we wouldn't have laid any money there, so that's okay. What's more interesting is that our model sort of turned around fairly quickly. By beginning of December, late November, it was already flagging Leicester as probably likely to do something. And if you look at the price there, at the beginning of November, you were still able to buy Leicester in the betting markets at a price of 3.25, so in probability terms, that's about 30%. Not just to win, but to finish in the top 6, which, if you think about it, based on their performance this year, is quite incredible. They had a 30%. They were priced as having a 30% chance to finish in the top 6, not to win, midway through the season. And this was after Jamie Vardy's record-breaking run. So, what does this say? Well, on the one hand, yes, we can profit personally for that, but also, this is very interesting information for our clients. We would potentially be, flagging this kind of stuff to them. We can flag it up as, here's a great example of why the markets are inefficient and potentially something you can do about it. So yeah, we do think the whole thing works. Right, I'm conscious I haven't talked about any Erlang yet, but don't worry, it is coming. We got some interesting problems at Sportsrisq. So team matching, how many different ways can you name Manchester United? How many different ways can you say Borussia Mönchengladbach? What if you get accents in this mix? Well, the problem is all the data that we get in from the web, it all needs cleaning. There's no central naming repository for all these team names. So, we have to run them through various different matches, exact matches, partial matches, abbreviation matches, Levenstein matches. Levenstein matches are very interesting. They're sort of fuzzy string matches. I don't know if people are interested in algorithms, but you should look up the Levenstein fuzzy string match because it's very interesting. And then you've always got the irregulars as well, Spurs and Tottenham, Saints and Southampton, no algorithm is going to be able to deal with those. So, we have a whole module dedicated to team matching, for example, traditionally written in Python, but now written in Erlang. And I'm indebted to my friend Robbie Rashka of Erlang Solutions, who we worked with on some of this stuff, and he actually wrote an open source, a small amount of open source code called Erl Fuzzy Match, which you might want to look at if you're interested in that sort of thing. And a free idea, yeah, QSIPs for sports names. Well, in the finance world, you have these things called QSIPs, which are like global identifiers for every security that you trade. You have nothing like that in the sports world. So maybe there's a business for actually QSIPs for sport names, where none of this team matching stuff would be necessary. It would certainly make an interesting software as a service project. Just a thought. Parallel events. Okay, this is where we start to get a bit more Erlang-y. So this speaks to the sort of parallel nature of the problem. On any Saturday afternoon, we have matches going off at various different points. I put them every 2-hour brackets, but it should have been every 1 hour. But at 2:30 in the afternoon, you have all the Bundesliga going off. 3 p.m. you have the Premier League, then you have a late Premier League game, there's some Spanish games, you have a whole lot of French League One games at 7 p.m., and then you have some 9 p.m. games as well. So potentially you've got to trade all these in parallel. Something that is hard for Python, even if you're doing event-driven Python or you're hacking Python somehow to make it look like Node.js, it's not ideal, at least in my estimation. But you can see that having trading processes that run in parallel to handle all these matches, makes it a very, very sort of natural Erlang fit. Even if you don't know anything about Erlang, other than it's good for parallel concurrent work, you can see from a chart like this that this might be a problem that Erlang can potentially solve. Contracts. Okay, so this is just the last in a series of slides about some interesting problems that we face. So in addition to long-term markets, we also are active in the short-term markets, which are bets or hedges on what's going to happen on an individual match. And often we want to try and find out what is the best value, in a particular match. If we have a hedging position, where should we be actually executing that? Match odds, Asian handicap, can we do something with correct score? Now the thing is here is that all these, well, I'm going to go back a bit and sort of explain what all these contracts mean. Match odds is probably something you're very familiar with. It's just who's going to win, who's going to lose, and who's going to draw. So if you look at the match odds thing, the home team are down the vertical axis, and these are the numbers there relate to the number of goals the home and away teams score. So down the vertical axis, you've got goals scored by the home team. Down the horizontal axis, you've got goals scored by the away team. So anything in blue on the match odds signs means the home team's won. Anything red is the away team. Down the middle in white, that's where the draw lies. Now, all the axes for these different charts are the same. The Asian handicap's a bit like a match odds, except there is a handicap applied to one side or the other. So instead of saying, are Liverpool going to beat Everton? You might say, are Liverpool with a handicap of 2 goals going to beat Everton? Something like that. And that starts to look very like match odds. It's just that the split between the blue and the red zones gets shifted along one of the axes, along the top left to bottom right axis. Total goals is very similar. It's just a question of whether you're in combination, the two teams score more than a fixed strike or score less. And correct score is simply whether you guess the correct score correctly. But the interesting thing about this, I don't want to belabor it too much because we need to go on to tech, is that all these contracts basically are functions of goals. So, a match odds contract is a function of goals, Asian handicap is a function of goals, total goals is a function of goals. So there's interesting problems figuring out things like, okay, if you have different prices for different contracts, such as these on the same match, which is the most efficient, which is the cheapest, which one would you want to hedge in? Again, something we started out with a Python library, but now have an Erlang library for. So, okay, bit of code, but not Erlang just yet. So traditionally, we've done all this stuff with App Engine, Google's App Engine program, and we're big fans of Google's App Engine. I don't think it always gets a great press, to be honest. You hear a lot of people on the web complaining, oh, it's expensive, or it involves lock-in, you have to use Google libraries, blah, 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 don't like this, don't like that. The fact is, App Engine is absolutely great. You get to work in Python, and increasingly it feels, in this space that everyone's working in Python, and you should read the link there, about why that's happening. And it's called I call it the Everglades effect because of the. I don't know if you read about release of pythons into the Florida Everglades, and they've eaten all the wildlife, and there's nothing but pythons there now. Well, it feels like that's what Python's doing to R and MATLAB and a lot of these other things. So you get to work in Python, so that's great, and it means that you've got lots of talented people out there that you can work with to do App Engine applications. Auto scaling is great; it's done it all for you. Deployment done all for you. They have lots of great sort of non-standard libraries that deal with memcache, email, fetching URLs that don't come with the normal Python stack. And they have tasks, which are absolutely great, which you can just fire off processes to run in the background, that can fetch URLs, clean data, run models, do whatever. And the overall effect, are you Erlang in disguise? I mean, sometimes it feels that way. Sometimes it feels like Google have taken what Erlang can do and tried to put a Python type front end on the whole thing, or make it work in Python. Now, it's not exactly the same, obviously, because I know all the Erlang purists are now going to say, well, Erlang has these lightweight threads, and every time you spawn a Python thread, you're not really spawning a Python thread, you're having to launch a new interpreter, and that's all true. But at the macro level, if you're just building an application and trying to run a business, App Engine actually does a pretty good, impersonation of probably the basic bits of Erlang. So if you're working with Python and you're just working on the desktop, you're not ready to take an Erlang step yet, you should probably check out App Engine and what it can do, because you can get a long way down the road of building a scalable application with it, even if it's not quite at Erlang levels. But App Engine the bad, right? Lock-in, you mentioned. Locations, well, it can be difficult because you have to. Google only have a certain range of locations, regions where you can host servers. Maybe not a big one. Cost is a problem because it's expensive. I mean, effectively, you're outsourcing the system administration function to Google, which can be a pain. It does get expensive, and we certainly spend quite a lot of time actually optimizing the cost with respect to App Engine. So it's not perfect. Bigger problems, task atomization. I mean, this starts to get to be a really big problem with App Engine, because the thing about App Engine, or the thing about Google, is they want everything. They want you to do everything in tiny sort of chunks. You can't, if you're used to sort of taking two giant databases, performing an SQL join on them, and it taking 2 minutes, you can forget about doing that with App Engine, because they want you to do everything inside a sort of 10-second window, which means you can only fetch a limited amount of data, and you have to spawn lots of tasks and end up with sort of MapReduce-like processes to make it all work. It's not impossible to do, but sometimes you're just like, golly, this really should be a lot simpler. There's got to be an easy way than sort of smashing these data-related tasks apart and then gluing all the data back together, which is generally the only way to do it. So that is a pain. And the thing that really got us for what we do is a task scheduler, which is that if you want to try and do stuff at fairly low latency, so inside of, around the 1 second mark, it's just not possible, because you're very much at the mercy of Google's task scheduler. And, Google doesn't think you should necessarily want to run tasks on a precise 1 second interval. So they will accept your tasks, but if they decide to run it 10 seconds late, well, they don't really care. It's just if the task queue's delayed, it's fine. Google said it's fine. Well, it may not be fine to you, especially if you're running a sort of business that needs to run on a 1 second frequency. So ultimately, I would say the task scheduler with App Engine is probably the thing that broke the straw that broke the camel's back for us, and forced, well, not forced us, but gradually led us to the awareness that we should be looking elsewhere. And here's the standard 3-tier web stack, which you're probably familiar with. Not particularly interesting. I'm going to augment this in a second, but you're familiar with sort of browser at the top, the web layer in the middle, and then the DB at the end. And I think what happens is a lot of people start out with a structure like this, and then they want to do something like this. Okay, so they say, okay, right, I've got this basic 3-tier web structure. Now I need some feeds to go in it. Now I need some tasks, workers to do stuff in it. But the problem with the 3-tier structure is the only place really to connect your feeds and tasks and workers up is via the database. And you end up with this horrible anti-pattern, which I think is called database as a router, where really what you want to do is you want to stream data from your feeds, via the web layer direct to your clients, or you want to do the same with your workers. But the only way to do it is via the database. So you end up with tasks pushing stuff into the database, and you end up with other tasks which then pull stuff out of the database and push it to the web layer. And the whole thing is basically just an unholy mess. So my advice to you is if you basically find yourself in that position, just say no. Don't do that, because that is a bad thing, and will lead you to lots of pain. And I have seen it in the past, and it has generally not turned out well for myself or for a number of other people I can mention, but won't. So if you find yourself doing that, just don't do it. Really, you should be looking at something completely different, which looks more like this. Okay, and this is I guess what you would call a message-based architecture. And again, this may be old hat to a lot of the people out there, but certainly when this was new stuff to me about 2 years ago. And initially you think, well, why would I do that? But actually, when you come to think about it, it makes a lot of sense, because the biggest problem, or the problem with the database as a router structure, is the fact that the linkages between all the different components are hard-coded. Right? They are completely centralized. So you have a hard-coded link between the database and the web layer. And the big problem with that is that's basically what then forces you to connect your feeds and your workers up to your database. Now, what the message-based architecture does is it decouples all that. Okay? So you have a big message router sitting in the middle, and you have all the other bits of your application sitting around the outside. And that's really nice, because then your workers can connect up to the message router, your feeds can, your database can, and your web server can as well. And it makes it much easier to route stuff between different components in your architecture. So, if you want your feeds to go into your database, that's absolutely fine. You can. Let's have a quick drink here. If you want your feeds to go into your database, that's absolutely fine. If, however, you want to stream your feeds to some clients, that's also very easy. They just go via the message router. So adding a message router into the middle basically gives you an awful lot of flexibility with respect to your application architecture. So we're moving from the sort of general sort of 60,000 foot view here is a movement from a standard 3-tier web architecture, which I think lots of people know and are familiar with, to a message-based architecture, which I think less people are familiar with. That's the general story. Now, of course, why Erlang? Okay, well, actually, let's go back a bit. Let's just go back a sec, right? I'll talk about the message router in a minute, but why use Erlang for this? Because the truth is, if you've got a database, feeds, a web server, and a workers effectively as satellites orbiting your message router sun, well, you don't have to write them all in Erlang. You could write them in whatever you want. You could have stuff in Python. You could have stuff in Ruby. Why Erlang? Well, this slide from the Elixir book did it for me. It's basically because it's just one technology to do everything. Instead of, given that we're a fairly to a couple of pieces. You've got your message router, which we'll talk about in a minute, and then you've got your actual app itself, which has a series of processes within it, which handle all the different components. So your database, your processing, your feeds, you name it. Erlang can basically do it. So it was definitely the sort of one-stop shop aspect of Erlang. The fact that within a particular application, you can have all these different types of processes written in Erlang, all under the same Erlang release, which was very, very appealing. And at the same time, it has less of a sort of Heath Robinson feel to it. I don't know if you're familiar with the term Heath Robinson. It's a sort of English phrase, and it means sort of jerry built, like you hacked it all together. You can hack all these different Ruby on Rails, Go, Redis stuff together. But does it really feel good at the end? Does it really feel maintainable and sustainable? I would argue, possibly if you're good, but maybe I'm not good enough, or maybe I just don't feel that way. So for me, doing all those components in Erlang felt very natural, and a very good way to go about the problem. So messaging, RabbitMQ. This is RabbitMQ. Well, actually, it's not RabbitMQ. This is actually, I think, a Buchla modular synthesizer. But whenever I think of RabbitMQ, this is what I think about. It's basically just a mass of wires that you need to plug in. And, if you plug stuff in the right way, you're going to get certain behavior. I don't know if any of you have ever played with something like a modular synthesizer, but you have sort of oscillators and filters and amplifiers, and if you plug different things in different ways, you make all these funny sort of wah, 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 wah sounds that are beloved of people in nightclubs and stuff like that, and it can be a lot of fun. But the big problem is if once you've wired something up, the problem is if you change the wiring, you can never make the same sound again because you've forgotten actually how you wired it up. And that's very much how I felt about Rabbit, because the big problem is that, well, it's not a problem necessarily, but Rabbit has a very complex topology. Rabbit is just to go back a bit. Rabbit is we're now talking about the message router, right, within this structure. So Rabbit is what we chose as our message router. Now, I guess that there's a number of different options we could have chosen here. I think the fact that Rabbit is itself was written in Erlang probably helped. Probably also because the ESL guys also, suggested that the pattern would work well. So we chose Rabbit as our router. But vis-a-vis the wiring, certainly from the perspective of a newcomer, it's quite complex topology. You have connections, you have channels, you have exchanges, you have queues, you have routing keys, and the behaviors that you get from Rabbit very much depend on how you wire up these different components in different ways. And it may be very intuitive to a Rabbit MQ specialist, but it's definitely not that intuitive to a newcomer. I did go on the Rabbit MQ mailing list at certain points and ask questions. And they were friendly, but they weren't that friendly. They were very much like, I wonder why this guy isn't getting it. But it wasn't clear to me at all. And we had a devil of a time with one pattern, with a worker pattern, where I hadn't figured out that actually the unit of concurrency was an individual channel and was not a queue. And we spent a number of weeks. Was it that long? We certainly spent quite a while trying to figure out why our worker pool wasn't getting any parallelism before finally hitting on it. Again, with ESL help, thank you, and it worked fine. So wiring stuff up in Rabbit, initially can be tricky. But that said, what we found is that there's very much an 80-20 principle at work here, which is that a couple of patterns give you almost all the value. And in particular for us, it was a PubSub router and a worker pool. And once we had got gen servers which encapsulated those two patterns, they worked very well. Rabbit worked pretty much without a hitch, with routing messages left, right, and center without a problem. And we didn't have any troubles. I mean, so much so that we thought maybe these things should be baked in at the language level, but perhaps Elixir does that now. So our PubSub router, let's go over this quickly. Actually, I'm not going to go over this quickly. I'm gonna just leave it for later because I'm looking at the time. I mean, these were the particular facets of our PubSub router. This is basically the wiring for our PubSub router with prefetch count equals 1 in italics, because if you get that wrong, you're going to be in a lot of trouble. And the 4 bullet points at the bottom were the API that we eventually came up with, which described our PubSub router. So any client wanting to subscribe to the router just used those four API methods at the bottom, and it worked out very simply. Worker pool, almost exactly the same, slightly different API at the bottom. But if you take time to go through the bullet points at the top, you'll see that they are slightly different. There's a gen server in this case. I think the PubSub router used a topic exchange. This is a direct exchange. We had to declare a couple of extra records. The queue behavior was different. The way workers bound to queue was the way workers were bound to queues was slightly different. But once this was working, this worked fine. I would say that there was some good documentation on RabbitMQ with respect to Python clients, which uses a library called PyCat, and we basically just translated those patterns into Erlang, and it worked out very well. A bit of code. Okay, I didn't want to show too much code, but this is just to show how simple it then was to build a client. Which in this case subscribes to the RabbitMQ PubSub router. So again, apologies if you're not Erlang proficient, but hopefully if you are Erlang proficient, you'll see that this is fairly simple. All you're doing is on initialization, you're asking the gen server to subscribe, and when it does subscribe, maybe I can just move my mouse and see the bits here. I'll try doing that because I'm sharing screens, aren't you? So here we are. Up here we are initializing the router with a set of routing keys. We ask it to subscribe over here, which causes a timing message down here to be generated. Now in this method here, we actually subscribe with our routing keys and generate a consumer tag, which is added to the state. And then once we've done that, there's a termination method down here to unsubscribe. But once we've done that, this gen server can happily receive any messages that come from the router, provided they match the routing keys that it's subscribed with. So you see that in this handle info block here, the first thing we do is we acknowledge the delivery track, and then I've commented, now need to do something with payload. And that pattern worked very well for us. We have a lot of subscribing clients to our PubSub router, which orbit this message router sun. No more code, I promise. A Manning style cache. Okay. A bit about application design. I mean, we started, because we were new to Erlang, we started off generally building everything as kind of like a giant big ball of mud pattern where everything was into the same application. And my friend Robbie Rashke said, no, that's not the way to do it. You should be designing separate applications. And of course, being a newbie, I was like, what do you know? I'll do it this way. But of course, he was right, and we figured it out over time. And eventually, we ended up, this is the next few slides, with quite a few different applications which are all bundled together under the same release. And I think one of the most interesting is the idea of a cache. And I call this a Manning style cache because it's laid out in detail in the Manning book on Erlang and OTP, which is a very good book. And this is an interesting example because it describes about how to build a cache in Erlang. And when you first come across it, it says what you should do is you should have an individual process for every value in the cache. And you look at that and you think, how can that possibly be true? That just doesn't make any sense at all. This thing is going to be so inefficient it will never work, and I could do it much easier in the language. But as you get deeper into it, you realize how much sense that makes, because you realize that, well, the moment of the light bulb moment for me was when I actually needed to design a cache which had timeouts for their values. So I don't think this is actually in the book, but every value in the cache I needed to time out after 60 seconds or at a particular time, and I realized that if every value in that cache was described by a gen servers crucially have life cycles which you can describe as permanent or temporary. And you can set up a temporary gen server which expires at a certain point. And when I figured that out, I was suddenly like, oh my golly, that makes so much sense, because you can create all these processes which have explicit life cycles, and you can set them up with certain ages, and then when you want them to expire out of the cache, they just disappear. And that truly was a light bulb moment, because I considered, how would I do that in Python? And how I would do that in Python involved some unholy sort of sweeping method that would clean up various processes after a certain time, and just thinking about it disgusts me slightly. But the Erlang way of doing things for that cache really is absolutely brilliant. And I think if you are new to Erlang, it is well worth buying a copy of the Manning book and just implementing the cache as they describe it, and then thinking about what you would need to do if you wanted to implement a cache timeout. That would be one of my key bits of advice for anybody who really wants to get Erlang. And by get Erlang, I mean not just the language itself, but actually the sort of OTP level and the sort of layer of application design. So get the Manning book. Port client. Oh, it's more code. Can I really go through more code? I'm just going to talk about ports in general. Ports were a big win for us. Erlang is not known as the fastest language. In terms of clock speed, I'm guessing it might even be slower than Python. But what it is absolutely great at is interfacing with other languages. And in particular, we have all our algorithms that we described earlier, and various others that I didn't describe, are written in Go for speed. And we found that it was very, very easy to interface Go processes with Erlang via ports. And actually the code is sort of just at the top here, and literally it's as simple as opening a port with a defined external calc server, pushing a request to the port, and then receiving all the results back from the port, and that's it. And it worked very, very beautifully, and I have some experience working with sort of trying to interface Python and C, which is definitely not a beautiful process at all. But again, one of the things that's not always apparent from the start is just how well Erlang does interface with other languages. And you can do that with at various levels. I mean, with Golang, I don't think there was an explicit Golang port library, so effectively we just hacked it. And what we did, this is actually a bit of Golang code here, and we basically built a very simple JSON interface where some JSON was passed over the port with this delimiter here, just a /n delimiter. And then once the delimiter is reached, the Golang process determines that the request's been received, runs an algorithm over it, and then returns it. So it was a very, very basic sort of API, but it worked incredibly well. But also you have explicit libraries for other languages to interface with Erlang via ports. I mean, there's a project out there, a GitHub project called Erlang, which does the same for Python and Ruby, but at a much higher level. And we had a lot of success with that. And so Erlang is a sort of interfacing language, because you have to accept that Erlang is, it's not going to be perfect for all parts of your application, but it becomes very easy to glue various other bits in, which has been a big win. MapReduce. Well, this harks back to some of the models that I talked about earlier. This is a kind of pattern that we do an awful lot when we're concerned with scenarios. Because for every mark that we generate, we're always concerned with, okay, we've got a match coming up. Let's take a match, Liverpool versus Everton. What often we need to know is, okay, what happens in a home win, what happens in a away win, what happens in a draw. And this sort of, you can map this very successfully onto a MapReduce pattern where you fan out inputs. You fan out a set of inputs for each of the different matches. You get them to calculate, in this case, each one with a Golang process, marshaled by Erlang, and then you fan them back in and actually calculate the net changes under each one. So this is just a MapReduce pattern, but we do an awful lot of this within Erlang, and worked very well. And you can see our MapReduce router in this. This is how our core pricing model works, and each unit on this page is effectively an application in itself. So again, if I had written this slide when we first started, there would just be one big circle in the center of the page, which is just like one big application. But ultimately, we managed to split it out into a whole series of different applications, which could be used in various different projects. So we ended up with a RabbitMQ worker pool, which we talked about, a MapReduce router, which then fanned out tasks to the worker pool, such as our risk generation process I talked about there. The PubSub router, which was basically responsible for routing messages within the application, and then the core pricing model itself. And with, once we had actually managed to split it out into these separate applications, it becomes very, very manageable. What had seemed, at least on our first iteration, to be quite a complex application, with a lot of different components in, once it was actually split down into separate applications, it seemed very manageable. And it was useful because a lot of these components on the left-hand side of the screen were able to be used in subsequent applications, and potentially will be used in the future as well. Algo Traders. So this is a more complex application which we use for hedging a lot of our positions over various matches on every weekend, and we ended up with a lot of different applications here. I'm sort of emphasizing a lot of applications here because, again, this one started out as one big application, but we ended up with separate applications for the Manning cache, which I talked about, the PubSub router, the team match stuff, which I talked about, and then various betting related applications as well. One to do with authentication, another to do with data feeds, bet feeds, and then an actual broker to place bets as well. So a more complex application, but again, one which has worked fairly flawlessly, I would say, over the course of the season, all ably marshaled by the PubSub router, distributing messages between these components. Okay, a quick thing on application design. So yeah, the sort of one of the themes that I've been trying to push over the last few slides is, we started out with one big application and then we gradually broke it down into components. It's not always easy to see or to decide where your different components should lie. I mean, this is a problem that we face, that you have a number of APIs within the industry. Betfair, Matchbook, and Pinnacle are names you might recognize. They are betting APIs. But within each of those betting APIs, there's various different sort of aspects to those APIs. There's authentication, market data, and then the sort of bet inventory as well. So the sort of problem, the application problem grid, if you will, looks something like this. Now the question is, how do you cut it? Do you cut this thing you don't want one application for each of these 9 blocks, right? What you want is more. You need to decide whether to cut the problem vertically or horizontally. So which way would you do it? Well, if you come from the Python world, you would probably say, I'm going to do this vertically. So I'm going to have a Betfair library which encompasses authentication, market data, and bet inventory, and I'm going to do the same for Matchbook, and then the same for Pinnacle, and that's the way I'm going to do it. But in actual fact, we found it much easier to do it horizontally, which I find sort of slightly counterintuitive, but it became quite clear that sort of all the authentication realm for different APIs, should be done in one application. All the market data stuff should be done in a separate one, and all the bet inventory stuff should be done in a third. And of course, if you're building stuff in Erlang, these betting aspects won't be directly related to you. But my point is, in general, if you're new to Erlang, it's not always easy to design your applications up front and get them right, get the cross-cutting aspects correct. It's fine if you're well versed. It's fine if you're well versed in the problem domain and you have a lot of Erlang experience. But I think often application design, and by application design I mean Erlang applications, which has a specific meaning. It's almost easier to build everything as one application to start with, and then reflect on what you've got and start abstracting different components out of what you've got in order to make things more manageable. Now, yes, Erlang Solutions will say that's definitely not the right way to do it, and I agree, but you will probably learn more by starting with one application and cutting it. That would be my advice. Right, we're sort of nearing the end. I'm conscious it's 10 to 5. So a few things that worked well for us. Erlang.mk. Yes, there's always this holy war between rebar, Erlang.mk, various different other things I don't want to get into. Erlang.mk is great, however. It makes dependency management really easy. It made release building really easy. You have a few key commands that you use. The guy who runs it, I'm going to mangle his name now, but I think it's Loic Ogouin. He's a French guy. He's a really nice guy and is incredibly responsive to changes and ideas and problems that you may have. He's great. But from my perspective, Erlang.mk really made working with Erlang a practical proposition. I had a bit of experience before with makefiles and rebar. Coming from Python, it wasn't that great. But working with MK, Erlang.mk really actually made working with Erlang not exactly as easy as working with Python, but not far off it. And it certainly removed a barrier for us in terms of making Erlang a practical proposition. So I would say, if you're so-minded, check out Erlang.mk. It's really great. Logging. We had a great experience with an application called Papertrail, which looks like that. Come back in a minute. And a library called syslog. So Papertrail is basically a logging application which uses the syslog protocol. We were generating a lot of log data because we're running stuff at once every second. We're running a lot of process at once every second. And how do we log? Do we use Lager? Do we use something else? Do we set up our own logging thing? And I got a recommendation off the web by a guy called Patrick McKenzie, and he said, use Papertrail, it's absolutely brilliant. And he's right, it is absolutely brilliant. All you need to do is you need the syslog library, which is done by a guy called Tobias Schlager, a German guy. He is also a very nice guy and very responsive. And literally, it's a single line of configuration in your Erlang.mk sys.config file. And then once you've got that set up, info messages are just one line, very, very similar to how they were in Lager. But you've obviously outsourced all your logging. You don't need a logging server or anything like that. So for a startup or a small business, Papertrail and syslog is absolutely great for logging. And I would say, if you're generating a lot of log files, go and use that. It's a big win. That's what Papertrail looks like. So the Papertrail interface is really lovely. I feel I'm pushing this a bit too hard now. Never mind. But if you've ever used Google's Cloud Console logger, I mean, the thing is literally like wading through molasses. It's so slow, it's just unmanageable. And Papertrail, by contrast, is an absolute delight. It's incredibly reactive. You can set up alerts and filters. It really gives you a window onto your application. And assuming you're going to be doing stuff at fairly high frequency, I would say a good logging solution is pretty much essential. Next, deployment. A little bit on deployment. We hack our deployment together. We don't do anything particularly sophisticated. We use EC2. We use Python and Boto to deploy our releases to EC2. The great thing about Erlang.mk is it just binds everything together in these Erlang releases, which can then be tarred up and copied to EC2. So it's a very primitive deployment. We don't do anything sophisticated particularly, but it works just fine. We are potentially going to look at Ansible, which I think automates a lot of this stuff. I'd say the message here is, yeah, if you're building Erlang releases, you probably don't need that, at least if you're working with a single machine, you probably don't need that much. You don't need too complex a deployment configuration to get something working with EC2. I have a feeling somebody's going to simplify the whole EC2 thing at some point because it's still too complex in my mind. But you can get away with just the bare basics with EC2 and Boto and get something going. So that would be my advice there. Right, a bit more advice. What can I only do in Erlang? If you're familiar with the Erlang community, you may have seen some of these quotes. I picked a few off the web. What can I do in Erlang is a great email worth reading. I mean, it sort of mirrors our experience exactly from a guy who started off in Python, was doing a lot of stuff in Python, and ultimately reached the limits of what Python can do, and discovered Erlang, and it solved a lot of the issues for him. And the phrase that really resonated with me is that we were doing this in Python without realizing. That is, basically writing an entire framework. If you find yourself writing a framework in Python to do something, you are probably doing something wrong, right? You would be better outsourcing it, and in particular, sort of something that looks anything like a middleware framework. You'd be better stopping and saying, okay, this has probably been done before. There's probably better ways of doing this. And certainly if you're working in Python, a better way to do it is to think about doing your infrastructure layer in Erlang and then plugging Python scripts into it using ports. But go and read the email because it's well worth it. One more. Erlang versus your favorite language. I won't say what your favorite language is because this one has an element of the flame war in it, and I don't want to start a flame war. But it's basically, again, it's an interesting thread about using Erlang versus using event-driven frameworks. Obviously, I won't name the language. Again, this really resonated with me because, consider going pure Erlang, which works exactly the way you're looking for it to work. You call a function, which passes around messages and gets the result for you, and the result comes back along with a function call, and all the not blocking is handled by the Erlang VM, totally transparently. And that really just nails the value proposition of Erlang, right? If you try it in anything else, you're going to be messing around with callbacks and, nested stuff. Maybe some of these communities have figured this out, but, they figured it out 25 years after Erlang has figured it out. And if you're trying to build a business, you don't want to be doing that. You don't want to be messing around with callbacks and stuff like that. You've got better things to do, like trying to grow your business and grow some equity value. So that statement really nails it, I think, with respect to Erlang. It's the fact that the non-blocking is handled by the Erlang VM. But again, go and read it. A bit of advice. Erlang.mk, use that. Cowboy is a well-known HTTP web server written by Loic Overeen again. He has some great examples. It's worth going through those. The Manning book is very good. What can I only do in Erlang? I just referenced. And Why I Program in Erlang is another link that I enjoyed by a guy called Evan Miller. And in summary, one of the most interesting things I think about Erlang is everyone thinks, oh, it's this functional language, and indeed, at the micro level, it is very, very functional. You know, it's a functional programming language. But once you get up to the application level, you know, everything starts to look much, much more object-oriented because you have these gen servers, which aren't exactly objects, you know, but they behave very like objects because they have state, and you have methods on them, you know, which change the state and they can do things. You know, and once you have, you know, a lot of these gen servers all connected together and talking to one another, you know, the whole thing feels like a very object-oriented system, but not a sort of flat, or, you know, some unmoving object-oriented system like you might have in Java or something like that, but one which is really alive, one that you can really inspect and you can monitor the messages between them. You know, and a very, very dynamic object-oriented system. And I'm sure I've seen somewhere, there's a great quote somewhere, and it might be from Joe Armstrong, it might be from Alan Kay. I couldn't find it, unfortunately, anyway, but it's something to do with the fact that Erlang is the most object-oriented of all languages, which, when you think about it, is quite a paradox, but it's very true. A few things on the future. So what does the future hold? Is App Engine dying? Well, no, because we're going to continue to use it. But I think, you know, the platform as a service market is going to change. You know, in 2008, I would have said that, you know, the platform as a service thing was going to stomp all over Amazon's EC2 AWS product. You know, and platform as a service was the way forward. Well, I could not have been more wrong because AWS is now $1 billion business, I think, in terms of revenue. And, you know, Google's commitment to App Engine, it's still there, but they're focusing on other ideas like Google Compute Engine and generally copying what Amazon are doing. But I still believe that, you know, the platform as a service market is going to be big. It's just it may need to change somewhat. You know, maybe the initial product offering wasn't ideal. And what Amazon is doing with AWS Lambda looks very interesting. That's certainly a next generation platform as a service model. Convox Rec is a startup which puts a whole layer on top of AWS to give it a platform as a service type feel. What else are we looking at? React. Everyone's heard of React. React is absolutely great. If you're doing user interfaces in anything other than React, then, you know, you're crazy, in my opinion. Except if you're using Elm, which looks even more interesting than React, and, you know, it's certainly next on my list of things to take a look at. Elm looks absolutely fabulous. Elixir I've put with a question mark because having used Erlang for a couple of years now, you know, I'm not sure I feel the need to move to Erlang personally. I mean, move to Elixir. I mean, I can see that definitely the syntax is appealing, you know, and if you're coming from a dynamic language, maybe it's easier that way. But part of me thinks about Elixir that it does too much trying to hide the underlying message passing. You know, it tries to make things too easy for everyone. And actually, you know, I should be a hard ass about it and just tell people to go and, you know, learn about message passing the Erlang way, because that's really what's going on under the hood. So Elixir is great, brings people to the platform and whatever. But, you know, personally, I'd go and learn Erlang. And finally, Reason. I saw this the other day. That was a new interface to the ML language. I have no idea what it's about yet, but it looks cool. And that's it. I hope you've enjoyed this presentation. I hope you've learned a little bit about Erlang and Python and how you might move from one to the other. If you have any questions, I'm more than happy to take them now. Or alternatively, if you want to get in touch with me after the presentation, that would be fine afterwards. That's it.
Justin, thank you so much for a very inspired talk on Erlang. I really, really enjoyed that. And, you know, we do these webinars once a month, but you've brought so much dynamicity and personal experience into the presentation, which is really where the value comes from. Now, I'd also like to thank everyone who's been asking a lot of questions. There's more questions we've received than we can answer, but we'll certainly try and justify and sort of honor as many of them as we can. So to get us started immediately, Justin, the first question I'd like to ask you from one of our audience is, how does AWS Lambdas play together with Erlang/Elixir? the member of the audience is basically saying it seems like all the advantages of the Beam are lost in the Lambda context. So again, how does AWS Lambda play together with Erlang and Elixir?
Golly, I have no idea off the top of my head. What I would say is, I mean, if you think about my sort of general message throughout this presentation, I mean, I'm a kind of practical guy. You know, I love Erlang, I think it's great, but I also think, you know, it's like different tools for different jobs. So one of the things you should take away from this is, yeah, we use Erlang an awful lot now, and it's brilliant for certain things, but we're not going to be abandoning App Engine or Python for certain jobs, because it's just great, you know, for sort of plain vanilla stuff that doesn't require you know, super high frequency type concurrency. I would say don't bother with Erlang, you know, don't. Just stick with Python, you know, stick with Python for what it's good for. So, you know, the Sportsrisq approach to different kind of tools is very much a polyglot approach, you know. We want to be driven by what's the best tool for the best job or for the current job, not by, you know, what do we want to play with today. Now, with that in mind, you know, the reason I'm pointing out what was it, AWS Lambda, is not to say merge it with Erlang. I'm not. I really don't know how you would do it or anything like that. What I'm simply trying to point out is that I think that's something interesting. It's on our radar screen as a very interesting tool for the future. And if you're into building practical type applications, it's something that I would have a look at. You know, how you integrate it with Erlang, yeah, I don't know because I haven't looked at it yet. But, you know, if somebody wants to go ahead and let me know, then I would be all ears, certainly. Sorry about that.
Thank you for that, Justin. I think that actually makes perfect sense. And thank you, Ori, for asking that question. Now,
hello? 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 Hi, I can't hear anybody, I'm afraid. I can't hear anybody. Can't hear anybody. Sorry. Maybe if I
the next question.
Oh, yeah. I can only hear you intermittently.
Process, or whether something is lost.
Mladen, are you there?
Okay, can you hear me now? Sorry.
I can hear you now. Sorry, I lost you.
Yes, I am. Yes, can you hear me?
I lost you for about 20 seconds. Could you repeat the question?
No, that's fine. That's fine. So Felipe is asking, how would you model an object-oriented world in Erlang? Could you equate a process and an object-oriented model, so to speak? I hope that question.
Can you hear me all right now?
I can. Yes.
Okay. Well, yeah, it's a good question. I mean, I'm not sure. If you ask Robbie Rasha, I mean, he would say that a gen server is very like an object-oriented singleton. Now, I am not an expert on object-oriented systems. I have, you know, not read the Gang of Four book on patterns or anything like that. So I'm not sure I can compare the two in a theoretical sense. But what I do know is that if you build an OTP application which has a lot of communicating gen servers, it feels very object-oriented because each gen server has its own state, which is very like a, for example, Java object. You can mutate that state, you know, with the aid of functions. You can get aspects of that state, and so on and so forth. And so, you know, my advice would be, I can't give you a sort of theoretical answer to it, but what I would suggest is, you know, if you're into object-oriented languages and you like designing things that way, don't rule Erlang out, because you may find that it's actually much, much more object-oriented than you think. And again, I would probably point you to the Manning book and the cache example. Or I would even say just experiment with a sample application which fires up a series of gen servers and try playing with them. Because again, the result will seem probably to you, possibly not, very object-oriented. And from my personal perspective, it's a very nice way of working. You can, once you have all these communicating processes, you can reason very simply about the system. And again, I mean, Erlang has all these tracing tools, which actually I'm not familiar with yet, you know, where you can actually go in and literally inspect the various messages between them. So I'm not sure, sort of from a theoretical perspective, how that worked, but I would say give it a go and give it a try.
Thank you for that, Justin. Let's move on straight to the next question. Larry is asking, is Erlang suitable for building things such as fix engines?
Fix engines.
Yeah, that's what Larry is saying, yes.
FIX.
Yes.
I would say I'm not 100% familiar with Fix. I know it's a financial protocol. I would say it's probably extremely good for building Fix type protocols, or at least applications which need to communicate over the Fix protocol. I mean, certainly, you know, for example, again, I don't know so much about Fix, but I'm guessing it is, you know, not dissimilar to you know, connecting up to a TCP stream, a raw TCP stream, and consuming that. And Erlang is very good at that, and that's something that's virtually impossible in Python, quite frankly. I also know that I don't know if you guys have heard of a guy called Sergey Aleynikov, or a book called what's the book? It was one of the Michael Lewis's book, but Sergey Aleynikov was the famous guy who worked for Goldman Sachs and was working in high-frequency trading, and was sued, I think, wrongly by Goldman for supposedly stealing some code. I don't think he actually did it and got off at the end. But he famously was an Erlang expert and did a lot of work of exactly this type. He went into Goldman and I think found that their systems were not that great. And ultimately started splitting it down into various different applications and, you know, cutting it down. He was an Erlang guru, still is an Erlang guru, I think, and still works in high frequency stuff. And I would bet my boots that, you know, he would have done a lot of fixed style processing within Erlang. And in fact, if you Google around the web for the name Sergey Aleynikov, you will probably find a lot in the Erlang space about that he's posted out. He certainly has an article out there about how to build a Gen TCP server in Erlang. So I would say yes, if you're looking at fixed protocols, Erlang is probably a very good choice.
Thank you for that, Justin. I can only apologize for everyone joining us for the webinar, as we're receiving questions much faster than we could possibly answer them. But we'll try and answer at least a further couple of questions.
Yeah, sure.
So Justin, one of our members of the audience is starting to learn Erlang. And this is actually quite an interesting one. He's basically saying he's been reading in a lot of articles that Erlang should be avoided for the reasons of CPU intensive tasks. Now, have you personally ever come across any such tasks, and would you sort of agree with that reason to avoid Erlang?
No, I would say it's absolutely ridiculous. I would say whoever wrote that basically doesn't really understand how Erlang works. Now, if you have a CPU-intensive task, the best thing to do with it is to write your CPU-intensive task in a different language, you know, that is suitable for fast CPU work, such as C, C++, or Go, and then have Erlang communicate with it via an Erlang port. And I can say from experience that works absolutely fantastically. So that's the first thing. I mean, even if you're just working at the single CPU layer, you know, you can do, you know, Erlang's perceived slowness is, you know, is just not an issue. You know, it's the same reason as it's the same reasoning which says that Python is slow. You know, a Python library is slow, but you know what you find is that actually it's pretty fast because somebody has taken the CPU-intensive bits out and has written them in C or C++ and is then interfacing them from Python. So, you know, what you need to think about is not necessarily a pure Erlang approach, but, you know, a mixed approach with, you know, your CPU-intensive bits talking to Erlang via an Erlang port. and that's just without considering the parallelism, so, already that you're going to get a pretty good speed pickup, by outsourcing the CPU intensive bit to go. But once you take into the fact that Erlang can do it in parallel, right, I mean, you're off to the races. I mean, your speed is only really down to the number of CPUs that you can harness. So, yes, I would say that Erlang is a very, very good choice, frankly, for CPU intensive stuff. Not that, you have to be careful saying that. I don't literally mean that in that you should write you shouldn't write an image processing library, probably, in Erlang. What you should do is write it in Go or C and then interface it into an Erlang application, if that makes sense.
I do agree, Justin. Thank you for that. And just to say, we'll move straight on to the next question, but thank you so much for everyone sort of posting the questions to our chat facility. Now, next question comes from Susan, and it's a bit industry specific, so Justin, you can sort of comment on it if you want to. I'll give a very brief response myself. Susan is basically asking, why do you think is Erlang so popular in the advertising community? Now, Susan, I can tell you that you're completely right. We have a number of customers and projects we have run in advertising. We have clients who serve 30 billion ads per day, and I guess that sort of answers your question. To achieve that kind of massive concurrency, scalability, and fault tolerance, people normally look at look at Erlang really as sort of the top tool for the job. Now, Justin, would you like to add anything to that?
Well, again, I don't really know anything about the ad industry except that, I understand that, there are people out there who are running sort of ad auctions and this, that, and the other, and real-time bidding for ads, stuff like that. That kind of problem looks very similar to sort of some of the problems that we have, where we're pushing lots of bets in parallel around the system. You consider a bid for a bid for a bid for an advertisement, for example. You could consider very similar to a bid on a betting exchange or a price on a betting exchange. So if you have a problem which involves a lot of these messages, these little bids and offers flying around the system and and needing coordinating, I would bet my boots that Erlang is going to be a good fit for that. I mean, the canonical example here is probably WhatsApp, right? I mean, again, they built some sort of giant SMS type machine. There's very little. I don't know anything about what WhatsApp do other than they run Erlang, but just thinking about what an SMS chat application involves, there's not a lot of CPU processing going on, but there is a very, very, very high number of small messages flying around the system at any one time that need routing from one endpoint to the other. That's the sort of defining characteristics of a chat system. Now you can see why Erlang's so good at that, because it's not a CPU dependent problem, and because it does parallelism and concurrency so well, it becomes largely just a matter of how many CPUs you can bolt on to route the messages around. So, my own Sportsrisq's own problems are not dissimilar to that sort of chat application, because you can consider, a lot of these messages that are flying around our system, whether they're for placing bets or for running scenarios or this, that, and the other. You have a lot of things that have got to be managed in parallel. And I would imagine an ad engine, although again I know very little about it, is not dissimilar. You've got a lot of people bidding ads. You've got a lot of people trying to sell ads. A lot of these bids and offers are going to be generated algorithmically. From a 60,000-foot view perspective, I would say that, the message flow probably looks very like a chat system, and ergo that probably Erlang is a very good choice. If I was involved in that sector, I'd say yes, certainly Erlang is probably the thing I would pick for that.
Thank you, Justin. I do have to apologize to our audience, but because we've already overrun on the time, we'll only be able to answer a couple of further questions. So, Justin, here's an interesting one, and before I ask it, I'll just say that we are not sort of into the types of conversations where you confront two languages and then try and sort of score points off them, so to speak. I mean, it's really all about right tool for the job. But one of our audience members is asking, could you compare Scala and Erlang, and what would your view on the two be?
It's very simple. No, I can't, because I don't know anything about Scala. So
Fine.
That's all I can say. But I mean, I know a little bit about Scala. To be honest, I have always shied away from Scala because I wasn't massively enamored by what I'd heard about it. But I don't want to, diss a language or a platform really without knowing anything about it. So I would probably, if it's okay, pass on that one.
No,
Except to
that's
say,
perfect.
I'm sure that Erlang is better, really.
Well, it really is, as you say, all about the use case and the specific fit of a technology. But just
Yeah.
to move on to our penultimate question, Marion is asking, what's the best way, in your view, to migrate from a language such as Ruby to something like Erlang?
Oh, okay. Well, that's a great question. I mean, the best way is to try some baby steps with Erlang, right? It is different. It's a functional language. It looks different from Ruby. It feels different from Ruby. You have this whole. It's not just different at the language level, but it's also different at the framework level. So in just the same way that writing an Erlang script is quite a different proposition from writing a simple Ruby script, so designing an Erlang OTP application, is quite a different proposition from, writing a Rails application, for example. They just but when you've got a bit of experience, you start to see the similarities. But when you're starting off, they definitely look very different. I would advise you just take some baby steps in Erlang, and try and get a few things running. Buy some good books. The Manning book is very good, but it's more on the application side. Joe Armstrong's Erlang book is very good, but that's just on the Erlang side. I mean, it's very much about practice. It's not as easy as, say, picking up Python from Ruby because they're quite different. What I will say is it's very worthwhile. It's a bit like learning a foreign language. If you're English, you want to learn German, you can't be fluent overnight. But if you can just try little scripts and little examples and get a feel from it, it is well worth it. But I think it's very much down to practice and small steps, but very worthwhile.
Thank you for that, Justin. And to try and sort of sum up with our final question, so Bib is asking, he's working on an orchestration project where he has to handle a lot of aggregations and transformations. And he's asking, do you think Erlang would be suitable for such a use case?
I guess I need to know what an aggregation and transformation means, because that sounds kind of general. I'm not sure really what in an aggregation of what and a transformation of what.
Yeah, there's nothing specified, but I do agree you would need a bit more detail. So
I mean, if it's a mathematical transformation or a mathematical aggregation, then I would say not. It sounds, if you're writing some algorithm, if you're writing algorithms in Erlang, then literally image processing algorithms, search algorithms, literally C-style algorithms, that's probably not the right thing to do. They're better off in a CPU-intensive environment. I mean, if you're writing an application which needs to do a lot of independent algorithm calculations, such as the one we're doing, or you could imagine something which needs to do a massive amount of on-the-fly image processing. Let's say you need to do a massive amount of on-the-fly image processing. Well, you wouldn't do the image processing itself in Python. I mean, in Erlang. You'd want to outsource that to C or Go. But you could have Erlang orchestrate the whole thing, especially if you've got a machine with a large number of CPUs. You could basically plug in image processing algorithms into Erlang via ports. And I think you probably have a very successful solution there, which would scale very nicely, because you get to use the CPUs very efficiently. So I think the answer, I guess I'm sort of inferring a bit what you mean by transformations and aggregations. But assuming you mean sort of hardcore, algorithm type stuff, then yes, I think it would work. but you've got to be careful how you're separating things out, how you're separating the CPU-intensive stuff from the actual application layer.
Thank you, Justin. Okay, I'm going to succumb to the temptation of asking one final question. I think we can sort of finish with this. So one of our audience members is asking, so what are your top 3 reasons for anyone to switch to Erlang? I just can't resist asking this.
No, it's a great question. I think, well, number one reason would have to be because the stuff works, right? It just works. You know, I got tired of writing stuff in Python and just eventually bumping up against its limits, you know, bumping up against the global interpreter lock, you know, bumping up against the lack of threading capabilities, bumping up against the, the lack of, native application, the lack of an application framework. I love Python, don't get me wrong, but it's not great for, writing applications. I got fed up. If you want to write applications which just work and you can focus on the problem at hand and building a business, then, Erlang is the one for you. Because you just, assuming you're doing things the right way, you just get into less bottlenecks, it seems to me. It scales effortlessly, and that's a really pleasant feeling. So that would be the first thing. The second thing, I don't know if I have 3 reasons, but I've probably got 2. The second reason is I really actually came to like the syntax, because you have to, ultimately what you find is you have to think a bit more about what you're writing. You have to think a bit, because you're sort of working within this application framework. Because Erlang is probably not quite as an expressive language as Python, you ultimately have to sort of plan a bit more about what you're going to write. How am I going to lay out this module? How am I going to get this layout module? How am I going to lay out this module? And I find actually having a sort of slight barrier to sort of, immediately getting down and writing code to be a good thing. I find I was probably actually writing better code in Erlang because I was forced to lay it out better within the context of these OTP frameworks. And I think having that OTP pattern to, build against is just a wonderful thing. You've just got this framework. You just have to lay out the code the right way. And yes, it may take a bit more time than Python, but it's actually a very, very sort of pleasurable thing to know that the sort of framework is there and you can sort of lean against it. And as long as you can write the code in the right way, it's just going to work. In many ways, it's a weird thing. In many ways, writing in Erlang is definitely more constraining than Python. But constraints sometimes can be liberating because ultimately, you're forced to observe a few more things than you would otherwise. But by doing so, it's almost as if the framework knows better, and the framework's saying, well, don't do it this way, just do it this way. And if you find yourself fighting the framework, you're generally doing the wrong thing. But if you go away and actually think a bit more about what you want to do, you're going to end up with better code. And so having the framework there to sort of code against, was a good thing. And there is a final reason, actually, which I think it's the only language which has really solved the concurrency problem. I may be wrong there, but everywhere else I look, if you're doing these kind of applications, concurrency is a big issue. I don't actually see any other solutions that get it right. Python gets it wrong. Node, in my opinion, gets it wrong. Any event-driven callback thing gets it wrong. Java gets it wrong because threads are awful. Akka in Java is just a copy of Erlang anyway. You may as well just program in the original. Will that do?
Justin, thank you. That I think was a very, very helpful answer. So we're getting questions as we speak, and we can't answer any further ones. Thank you all for asking them. I'm sure everyone will join me in thanking you, Justin, for a very inspiring talk. Many thanks to everyone who has joined us for the webinar as well. Please join us again for our next monthly webinar, and following today, we will send you a short survey to make sure that we capture your feedback of today's webinar. Please also note that the recording of the webinar and the presentation that was shared today will also become available for you to collect on Erlang Solutions' corporate website at www.erlang-solutions.com. Thank you all once again, and we very much look forward to seeing you on our next webinar.
Thank you.